How's it going? Welcome to day 39. Today we're going to be talking about how to determine when functions are increasing or decreasing. And we're going to do a little bit more work with critical points, talking about what critical points could be, and more specifically, determining what they are. So let's talk about increasing and decreasing first. So I'm just going to draw a graph on here. Let's say we have a graph right here. I'm going to call this f of x. And by looking at this graph, I want to determine where is f of x increasing or decreasing. Okay? Well, when I look at this thing, increasing means as we go from left to right, we're going up. Right? So I can tell we're increasing all the way from here to here. We're also increasing here to here, right? So what do those places have in common, right? Anytime a function is increasing, what do we know about that? Specifically, that's going to relate to calculus, right? We can say, okay, yeah, that's where it's going up. That's pretty easy to tell, right? But what would be true about the derivative of f? Well, in all of those places, right, the derivative of f prime just means the slope of the tangent line. What's true about all of these tangent line slopes at all of these different points here? Well, all of those tangent line slopes would be positive. How about where is f of x decreasing? Well, it's decreasing right from here until here. Right? What's true about the tangent line slopes here? Well, they're all negative. Okay? This comes to a very, very important definition. It's a definition that will always be true, and it's one that we have to be very careful about and understand. Okay, so here's the definition. F of x is increasing when f prime is greater than 0. So f of x is increasing anytime my derivative is positive, right? All those stretches, anytime I had a positive f prime, a positive tangent line slope, I knew that at that point in time on f of x was increasing. Okay? The other, so really, really important to have this boxed up and understand. That is always going to be true. F of x is always increasing when f prime is greater than 0. How about f of x is decreasing? F of x is decreasing when f prime is negative. That should be pretty simple and pretty intuitive to us, but it's easy to forget, right? So if I have a function, if they gave me on the test a function f, and I want to know when is f increasing, well, I just need to figure out where the derivative is greater than 0. If they gave me f prime, and they want to know when f is increasing, I would just take that f prime, and I would set it equal to 0, and I want to figure out where f prime is positive, right? I wouldn't have to do a derivative in that case, because they already gave me f prime. I would just need to figure out where is that thing greater than 0. Okay? Very, very, very important there. Let's do one practice problem with this thing. So I'm going to tell you that f of x is 4x squared minus 20x plus 3. My question is, on what interval or intervals is f increasing? So when we see a question like this, they're going to ask you this question, when is f increasing? And there are lots of different starting scenarios. They might give you f, They might give you f prime. They might give you a graph of f, although they probably won't because that's too easy. Or they could give you a graph of f prime. Okay? Any of those things are possibilities. Okay? In this case, what was given? Well, what was given was simply f of x. So I want to know when is f increasing. Okay? My definition, what I need to know immediately is f is increasing anytime f prime is greater than 0. So I need to figure out when is f prime positive. Right? When I get that interval or intervals, that will be the same as the intervals for when f is increasing. Okay? Now, since I need f prime of x, right? Since I need to know when f prime of x is positive, I need an expression for f prime of x. So the first thing I want to do is find f prime of x. Well, f prime of x is very easy to calculate here. We get 8x minus 20. Now, what we're going to do next is going to be very similar to some of the stuff we did in PVA. Okay? I need to figure out when is this thing, this 8x minus 20, I want to figure out when is it positive. For what numbers could I plug in that's going to make this thing positive? Okay? Well, that's going to be to figure out where something is positive, or to figure out where something is negative, I first need to figure out where this thing is 0. So even though I don't need explicitly f prime of x equaling 0 here, I didn't ask for the critical point. I just asked on what interval or intervals is f increasing. Well, to figure out where f prime is positive, I need to figure out where f prime equals 0. Right? And then I can do a test. So what I want to do here is I want to set my f prime of x equal to 0 and solve. Okay, well, this is pretty easy to solve for. I'm going to add 20 over, and I'm going to get 8x equals 20. Then I'm going to divide by 8, and I get x equals 20 over 8. 20 and 8 are both divisible by what? Well, they're both divisible by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. So I get x equals 5 halves. This is not my answer, because the question is I want to know when is f prime greater than 0, right? But it's really important to know my 0 so I can figure out what is greater than 0. Okay? So I know that f prime is 0 at 5 halves. That's the only point where that occurs. So what I want to do next, since I want to know ultimately when is f prime greater than 0, well, I know where f prime equals 0. F prime equals 0 at the number 5 halves. X equals 5 halves. So what I want to do is make an f prime number line here to test this thing. Again, I need to label my number line f prime. Don't just do a number line with 5 halves and 0 on there. Okay? Because as we get farther and farther here, we may have multiple different number lines going. And to keep them all straight, we need to be very accurate in our labeling. Okay. The next thing I want to do is I want to test values to the left of 5 halves and to the right of 5 halves to figure out the sign of f prime in those two different regions. So I want to choose a number less than 5 halves and I want to plug it into f prime. The easiest number to the left of 5 halves is 0. Right, when I plug 0 into f prime of x, I get 8 times 0 minus 20. Right, just plugging it in here. 8 times 0 minus 20 is a negative number. So I know that f prime is negative everywhere to the left of 5 halves. Now I want to choose a number bigger than 5 halves, right? 5 halves is 2.5. So I'll just choose 10, because 10 is an easy number to multiply. 8 times 10 is 80. 80 minus 20 is 60. That is a positive number. Okay? The other thing that I'm going to ask, I'm going to add this on what intervals is f increasing. I'm going to add the word justify to the end of this. You know me, I love to ask you to justify things. Okay? So now, when is f increasing? F is increasing every time f prime is positive. Well, we have no endpoints here, right? I didn't say we're only looking between 0 and 10 or something like that, right? So what is the left bound? Well, our left bound is 5 halves. Our right bound, this graph is going to continue increasing forever, all the way out to positive infinity. So I can say f is increasing on the interval 5/2 to infinity. And I need to justify that. A sign chart alone isn't not enough for a justification. We need words. F is increasing on 5/2 to infinity because that is where, now again, don't say that that is where it is positive. Say that is where f prime is positive. And easier than saying f prime is positive, I write f prime of x is greater than 0. Okay. Oftentimes our justification is just like we immediately can find our justification because it's what we're trying to do to solve the problem. Okay? Good. Next, let's talk about critical points a little bit. Again, we know this is from yesterday, or our last video's notes, said that critical points are when f prime of x equals 0 or f prime of x is undefined. Okay. But critical points are going to end up always being one of 3 different things. Okay? Let's think about slopes of 0 real quick. Let me just show you on a graph here. Okay, on this graph, I have 3 places where f prime appears to be 0. Okay? Again, f prime simply means, going back to our definition from the beginning, we should know this, but it's good to think about it again. That means the slope of the tangent line is horizontal, right? So when I look at this part of the graph right here, my tangent line slope is going to be a positive number. It's not going to be 0, right? But at some point in time, as I keep trailing along this graph here, I'm going to come to a point maybe right here. Right at that point, my tangent line slope is 0. Go ahead and find the other 2 places where it looks like I have my slope of a tangent line would be 0. Well, the other one would be right down here. And my third one would be right here. So those are the 3 places on this graph. And I'll label this graph as f of x. These are the 3 places where I see an f, based on f of x, I see f prime of x equaling 0. Well, what do we have in these little places? Well, what would we call this one? Well, this one is either, there's 1 of 2 terms. Sometimes we call it a local max. The other word that we call it means the same thing, is a relative max. They use both of these phrases interchangeably, so just be prepared for either calling it a local max or a relative max. Okay, so there's a local max right there. So a critical point could end up being a local max. But we see another critical point, our second critical point, going left to right, is down here. This one, so this one was the highest in its little area. This one right here is the lowest in its little area. So we call that a local min. Also called a relative min. So a critical point could be a local min, it could be a local max, or it could be neither. This third point right here, this is neither a max nor a min. So a critical point, right? Our maxes and mins are going to be critical points. But just because we have a critical point doesn't mean it's necessarily a local max or a local min. It could be neither a local max nor a local min. Okay. Interesting. So those are my f prime of x equals 0. Let's take a look at another graph. I want to talk a little bit about this. F prime of x is undefined. Well, we know from our differentiability talk yesterday, f prime of x is undefined when we have a corner or a cusp or a vertical tangent, something like that. So I'll make some weird graph here. I'm going to call this graph f of x. Clearly, this graph has 3 points where I'm not going to be able to calculate f prime. Right? 3 places on here, f prime is going to be undefined. I can't come up with an answer for the derivative. Those points are right here, and right here. So all 3 of these are critical points. They're not where f prime of x equals 0, but where f prime of x is undefined, right? I can't get a number of a slope of a tangent line at corners or cusps. Okay? Well, again, those critical points still could be local maxes, right? This would be a local max here. This critical point would be a local min, because it's the lowest in its area. This critical point is neither a local max nor a local min. So our places where f prime is undefined can still create local maxes and mins, because they're still critical points. And critical points have to be one of the 3 following things: a local max, a local min, or neither. Okay? So let's talk about a local max. Since critical points could be a local max or a local min, or neither of the 2, we want to come up with what's always happening at a local max. Again, f prime could be 0 there, or f prime could be undefined there, but that doesn't narrow it down to local max, because a local min is the same. So what's happening on a local max? Well, let's go back and look at our first graph. What is happening to f prime, right? Right here, f prime equals 0, right at this point. But what is f prime doing to the left and to the right? Well, on the left side of the local max, f prime is greater than 0. On the right side of the local max, f prime is less than 0. Right? Is that true on our one where f prime is undefined? Yeah, again, over here, f prime is positive. Over here, f prime is negative. For a local min, it's going to be the reverse. On a local min, the left side, f prime is negative, and on the right side of it, f prime is positive. So here's what we say. For a local max, at that x value, f prime switches, right? In both cases they switch, but f prime specifically switches from positive to negative. Okay? Box that thing up. That's very, very, very important. It's something that needs to be memorized from now until we take the AP test. A local min, however, is the reverse. F prime is still switching, but it switches from minus to plus. F prime switches from minus to plus. Okay? What about our neither points? Well, in this case, f prime was greater than 0. And in this case, f prime was greater than 0. Oops. F prime greater than 0. So f prime didn't switch signs there. Up here, f prime didn't switch signs here as either. So at neither, we just call them neither points. For neither points, f prime doesn't switch signs. So this is kind of like changing directions, right? In PVA. I always ask you, when did an object change directions? Well, you had to figure out when V switched signs, right? Well, same with local max, local min, and neither points, but we have to be even a little bit more detailed, because whether we switch signs from plus to minus of f prime or minus to plus of f prime changes whether it's a local min or a local max. Okay? If f prime doesn't switch signs, that means we have neither a local max nor a local min. So let me show you an example. F prime of x equals x squared minus 3x minus 4. I want you to find the critical points, find x values of critical points of f, and then I want you to tell me whether they are, or explain if they are local maxes, local mins, or neither. Okay, so again, my goal here is I want to find the x values of the critical points of f. Okay, we know from today's work in class and the video from the last video that I made, we know that critical points occur anytime f prime of x is 0 or undefined. Now the nice thing is I already gave you f prime of x. So do you need to do a derivative to solve this problem? No, you don't. We just have to take our f prime of x and set this thing equal to 0. So I want to take my f prime and set this thing equal to 0. Okay. So I have to think, what two numbers multiply to -4 but add to -3? Well, that would be -4 and +1. So I can factor this into x minus 4 and x plus 1. And that gives me x values of -1 and +4. So those are my two x values of my critical points. But now I have to determine, for this -1, is that a local min, a local max, or neither? For that +4, is that a local min, a local max, or neither? And I need to justify this. I need to explain it. Okay? So what we want to do now is we want to make an f prime number line. Again, always label your number lines. The two values I want in here are -1 and +4. So what I want to do now is I want to take a value less than -1 and determine whether f prime is positive or negative. When I take a value less than -1, maybe -2, right? I'm going to plug into the factored form right here. And again, I don't care about the number, I care about the sign. When I plug in -2 minus 4 is a negative number. -2 plus 1 is also a negative number. What happens when I multiply a negative times a negative? I get a positive. Now choose a number between -1 and 4. I'll choose 0. 0 minus 4 is still negative. 0 plus 1 is now positive. And what do I get when I do a negative times a positive? I get a negative. And now I want to choose a number greater than 4. I'll use 10. 10 minus 4 is now positive. 10 plus 1 is still positive. A positive times a positive is a positive. So these f prime number lines are very helpful, right? I would have done this if I needed to figure out where is f increasing. The answer to that question would be from negative infinity to negative 1, union 4 to infinity. Or if they asked me where is f decreasing, I'd say from negative 1 to 4, right? Because that's what the signs are telling me of f prime. But my question is, this x equals negative 1. Okay? I want to know, is it a local min, a local max, or neither? Well, how did f prime switch here? F prime did switch signs, so it is going to be a max or a min. Right? Take a look at how we changed here. Reading left to right, we went from f prime being positive to f prime being negative. That means it's a local max because f prime switched from positive to negative. Okay? So I know that x equals negative 1 is a local max. What I like to do to help myself with this is when I look at this, I think about what's going on, right? So I draw a little shape here. To the left of negative 1, my f was an increasing function. And then after negative 1, my function started decreasing. Clearly, this right here is a local max. And I need to explain that. X equals negative 1 is a local max because, not it switched, but because f prime switched from plus to minus. Okay. How about at x equals 4? At x equals 4, once again, f prime switched signs, but this time f prime switched from negative, meaning f was decreasing, to positive, meaning f was increasing. What does that look like? Well, that looks to me like a local min. Again, it's a local min because we need to explain this very carefully, because f prime switched from minus to plus. Okay, that would be a sufficient explanation. Okay, so I'm gonna wrap the video up right now. We'll take a look at this stuff on Wednesday in class to get ready for it. All right. See you guys later. 2 chains. Didn't forget this time. See ya. Bye.